Hello students, now we're getting into something exciting in the syllabus and we're going to talk about roots of complex numbers. We did this just a little bit in class, but now we're going to go into more detail. So if we think about the roots of a number, then we're thinking about solutions to some complex number raised to that power to give me the complex number that I wanted to find. So that's confusing. Let me say it another way. If I asked you to find the fourth roots of 16, well, we would be thinking of some number z to the fourth is 16. And this number, this value, I can actually solve. I know what the fourth root of 16 is, that's 2, but it's z to the fourth, so I have 4 potential solutions. So let's think about it this way. If I square root it, I would say z squared is plus or minus 4. And then if I square root again each of these, I would say z is plus or minus 2 from the positive 4 and plus or minus 2i. So now if I take any of these numbers and raise them to the fourth, I'm going to get 16. So let's test that with negative 2i. So negative 2i raised to the fourth, that's the same as negative 2 to the fourth, I to the fourth. Well, that's the same as 16 times 1, which is 16. So z to the fourth, I have 4 solutions. And in this case, I could figure out what those 4 solutions were. But let's say I gave you something like z to the fourth is equal to 2i. So that's what we're looking up here, the fourth roots of 2i. So we want the solutions to this, 4 different solutions. This is something that I can't just solve. I don't know what the square root of this is or the fourth root. So I can use de Moivre's theorem to help me. So I want to figure out the different answers to z. So I'm going to start by saying that z is equal to 0 plus 2i. So I just wrote this out in my a plus bi form, to the 1/4. So I move this to the other side. And now de Moivre's theorem tells me that that's the magnitude of this. So my magnitude of 2i is just 2. So I'll have, I don't need to write it in parentheses. So I'll have 2 to the 1/4 cis theta. So my theta could be, if I just graphed this, my theta would be pi over 2. But if I think about coterminal angles, I could have pi over 2, 5 pi over 2, and just keep adding 2 pi. But of course I'm going to do 1/4 of that, so I'll do 1/4 of pi over 2 plus multiples of 2 pi. The reason that I'm thinking about coterminal angles is because I want 4 different answers. So to get my 4 different answers, I'm going to let k be 0. So the first one, when I say that my argument is pi over 2, and then do 1/4 of that. But then I could also do my next 3 coterminal angles to give me a total of 4 solutions. So let's work this out. So I have for k equals 0, that z is equal to the fourth root of 2 times 1/4, cis of pi over 8, because I'm going to have 1/4 times pi over 2. So that's my first solution. Now if k equals 1, then my second solution is going to be the fourth root of 2 cis 1/4 of pi over 2 plus 2 pi. So if I work this out, that's going to be 5 pi over 2, and then I'll have 5 pi over 8. So I'll have 2 to the fourth cis of 5 pi over 8. So let's go back and test this. So does z2 to the fourth power equal 2i? Well, so z2 is 2 to the fourth cis 5 pi over 8. And now I'm going to raise that to the fourth. So again, de Moivre's theorem, I'll have 2 to the fourth times 4, cis of 4 times 5 pi over 8. So I'm going to end up with 2 cis 5 pi over 2, but of course this is a pi over 2 equivalent, so this is going to give me 2 cosine pi over 2, which is 0, times plus I sine pi over 2, which is 1, so multiply that by 2, and I would get 2i. So I could keep going to find my other solutions. Z3 is going to be 2 to the 4th times cis of 1/4 pi over 2 plus 4 pi, because this is going to happen at k equals 2. And then my fourth solution, 2 to the 4th cis 1/4 pi over 2 plus 6 pi. Notice that even when I work this out, so I'll have 2 to the 4th cis, so that's going to end up being 12 pi over 2, 13 pi over 2, 13 pi over 8. This is still less than 2 pi. So I'm still finding all my solutions are within 1 unit circle. So this is my way of finding all the roots of a number. If we're asked for roots of unity, those are the roots of 1, and we'll look at those in some upcoming examples.